All right, good morning, guys. This is the recording for both ACA and KAP today. So either one, just watch as we go. You'll have the same lesson, nothing too crazy. Today we're sort of starting our unit on, it's called our algebraic relationships unit. We're going to start doing math, and we are going to start having letters in our math today. Okay, whenever we have a letter, that means it's just standing for some unknown number, or it could represent multiple numbers. Okay, you'll get the flow of it today. Today's just a foundation day. It's nothing too crazy. You'll get the patterns and see the things. Ms. Idle will be writing math in other ways that we talked about. Like I'm going to be writing multiplication in ways that we've talked about this year, but maybe we've forgotten about it because it's been a little minute. So some of this stuff you'll just have to readjust to, and you'll get used to it over time. Okay. So again, the two things we're talking about today are additive and multiplicative patterns. Everyone say additive. Additive. Everyone say multiplicative. Multiplicative. Okay. Notice what two operations are we missing? Subtraction and division. There's no such thing as a subtractive or a dividative relationship because we can write subtraction as addition. We learned that when we talked about our integer rules. Whenever we subtract, we could also rewrite it as adding the opposite number. Okay, if I ever have subtraction, I can just rewrite it as adding the opposite. For division, think about fractions. Whenever we divide it by a fraction, we said it's the same thing as multiplying by the reciprocal. Very good. Okay, so there is no such thing as a subtractive or dividative because they fall in line, and we can rewrite them as those two. All right, so additive patterns. We're also going to talk a lot about inputs and outputs. Okay, you're going to be given a number, you do something to it, you get out a number. Put input, output. Very straightforward. Additive patterns is the rule or pattern that adds a number to the input to get the output. So again, input, we're going to use the letter X to represent our input. It won't always be the X, but it'll always be like on the X-axis of a coordinate plane. In a multiplicative pattern, the ruler pattern multiplies by the input, and that's how you get your output. You can think of it like as a factory or a machine, you know, like put something in, something happens, the machines do their magic, and then out comes a brand new car. So exciting.
Which car?
It depends on what you're doing. Okay, let's see. Okay, so we're going to look at some examples. Whenever you're given like a table or a graph or whatever, you're looking for what's happening, what's the pattern. Okay, so again, my X is my input, my Y is my output. Okay, you're always thinking, what are they doing to X to get Y? So let's look here. If I start with 0 and I get out 0, you could say that they're adding what?
0.
They're adding 0 or they're multiplying. Well, it could be any number because so sometimes you can't tell it on the first stick, so you have to go to the next one. To go from 3 to 21, you could either times 7 or you could add 18. Okay, so you have to sometimes look at a couple just to know for sure because your gut instinct isn't always the right one. To go from 6 to 42 times 7 times 7 times 7. And hey, let's go back to that 0 times 0. Does that work with the times 7? Absolutely. Okay, so my rule is I'm multiplying by 7 each time. Okay, again, it's always good to check because like we love, our favorite thing to do is like have the first one match one pattern and then the second one, like you might think, oh, it's going to be multiplication, but then it's really adding. You have to check it with the rest of them. Okay, so the way that we write our rule is we're going to show what we did to X. Now, this is the first time in a while that we've seen how I'm about to write this. Okay, so what we are doing, just take a second to watch, we are doing 7 and we're multiplying it by our input value. Okay, now, taking a second, when we talk about multiplication, this I'll mention at the beginning of the year, but hasn't in a while, I haven't mentioned that we don't write it like 7 times X. That looks weird, right? Because you're like, wait, which one's the multiplication sign, which one's the input value? Okay, we are going to get away from writing like this. We're going to get away from multiplication like that. In elementary school, it was great, it was fine, it was awesome. And now that we're getting into the algebra type stuff, we're going to take away this symbol and we're going to use alternate ways. If you're in this idle class or in another class at home, your teacher has an invisible math poster up in their room, and we have the different ways to write multiplication up on our board. So always remember that reference point is there. The way that Miss Lytle is going to get us used to writing it is just 7x. Whenever you have a letter, you can just write the number next to the letter, and that also means to multiply. Okay? It's a little different when you write it with a number, like if I wanted to do 7 times 3. I'm not just going to write 7 and 3 like that, because what does that look like? 73. Whenever it's two numbers, I'm going to put a set of parentheses around it just to help out. But just know that these two ways are how we're going to start writing our multiplication a lot in this school year. Okay, we're sort of transitioning into this junior high math, high school math type stuff. This is how you're going to start seeing it. So I just don't want you to be caught off guard when this Lytle starts not putting symbols with her numbers. Okay, so the rule is 7x because they're multiplying the input by 7. Now, is this an additive or a multiplicative relationship? Multiplicative, very good. Very good, very good. Okay, next one. We're putting in 3, getting out 10. Putting in 7, out 14. In 8, out 15. What are we doing? Plus 7. Plus 7. Does that work for all of them? Yes. Very good. Okay, you're not always going to have to fill in all of these little things. A lot of y'all will be able to see it quicker, but we're just showing that it happens every time. A rule is something that works every single time. Okay, so to write that rule, we're taking our input and we're adding 7 to it. Could I write 7 plus x? Yeah, it's the same thing. It's just the order. Okay, and so this is what kind of rule this is? Additive, because I'm adding. Additive. Pretty straightforward. Y'all go ahead and do the next 2 problems. Take 2 minutes. Ready, set, Matt. Pause and play when you're ready. Yes, sir. Take. Plus 9. So again, I'm going to include that x plus 9 because I'm adding 9 to what? I'm adding it to x. And this is what kind of relationship take? Additive. Y'all agree? Yeah. Okay. Again, you can fill in that plus 9 for every single one. I'm moving on for setting sake. So Samantha, what did you get for the next one? Times 5. Again, what are we multiplying by 5? The x. So I'm going to write 5x. Technically, you can also write this yellow x5. But that's weird. Y'all don't know that looks weird because we're like, that looks weird. Math sort of has grammar, kind of like English does. Okay, like when we write a sentence, we always capitalize the first letter, right? In math, when you're multiplying and writing it like this, you always put that number first. It's called the coefficient. So it's not wrong. This item will never count it wrong, but I will always fix it. Okay, the number should always go before the letter when you're writing multiplication. It's just math grammar. I will take off for it this year. In future years, high school teachers will probably take off for it because it'll just look funny. But again, we're just now getting used to it. Okay, and this is what kind of relationship, guys? Multiplicative. Great. Awesome. So now we're going to look at it on a graph. We looked at a table. We're going to now look at a graph. We reviewed graphs right before break for us, but it's nothing too crazy. So my ordered pair, they told us what we're doing right there. Our x is going to be our input value, and the way that we get y is we're going to add 1 to it. Okay? So does this table match that rule up here? Yeah. Did they add 1 to each input? Yeah. Yes. Okay? So we're just going to graph. So 0, 1. The 0 tells me I'm not moving which direction? I'm not moving to the right or to the left, but I am going to go up 1. Okay, that's 0, 1. Okay, 1, 2, I go over 1, up 2. 2, 3, over 2, 1, 2, up 3. 3, 4. Okay, we said each time, what was that pattern they were doing? X plus Fun, very good. Okay, hold this right here. All right, let's graph that other one. It's telling us, what are we going to do? Times 2, very good. Okay, so, 0, 0, that's called the origin. Okay, this goes through the origin. 1, 2 over 1 up 2. I'm doing this because I assume y'all are good to go. Okay, once y'all get those graphed, we're doing 2 times x. I want y'all to talk about, what do y'all notice about these graphs? What do you see as similar about both of them? What do you see as different? I want y'all to turn and talk to your table mates, right? So go. Dylan, what was one thing that you guys talked about? What was something?
We said that it goes up by the same amount every time.
In both of them, they like go, there's a constant rate, like one goes up 1 over 1, up 1 over 1, the other one goes over 1, up 2, but it stays constant. Great. What's something else, Etta? They're diagonal lines. Miss Lytle gave a word to that a few weeks ago. Do y'all remember? If it makes a line, it's going to be...
Consistent.
No, it is consistent. Slanted. It is considered to be linear because it makes a line. Y'all remember that? Okay. Did anyone notice the difference between the two? Bruna.
The blue one is longer.
Okay, it's the same number of points, but longer. Yes, Afton. Steeper. Okay, that's why it's longer, is because it's steeper. Yes. Very good. Okay. Tate said that the multiplicative one, he probably read through these little sentences down here that will guide you. He noticed that the multiplicative, aka that blue one, goes through the origin while the additive does not. Do y'all agree with that statement? Okay, so let's follow that in. Notice the line does not go through the origin on the red, the additive, but does go through on the multiplicative. Now, I want to see if that's going to be true every single time. Okay, so Ms. Lytle's going to go backtrack on the ones that we've already done. Y'all can just walk up on the board. Okay, on this one, we said that the rule was +9. So if I had 0 and I added 9, what would my output be? 9. Does that go through the origin? No, because that's 0, 9. Okay, over here, my rule was 5 times x. If I put in 0 times 5 gives me 0. Does that go through the origin? Okay, so that rule holds up. Let's go back. Okay, let's just look at lots of examples. We said our rule was 7 times x. If I put in 0, what would I get out? 0. Okay, works out. It's going to work every single time because if I multiply something by 0, it will always be 0. Okay, it will always go through the origin on a multiplicative relationship. Are we good with that?
Yes, ma'am.
Okay, here we go. So what's going to happen is you're going to finish up this packet. We'll go over it in a few minutes, and then that other paper will be your worksheet. We're going to pause and then play with yours. All right, here are the answers. Before I do show them, notice it did give you slightly different letters, but the input and output are like still the same position. It tells you what your input is R, so you're thinking, what are they doing to R to get here? Okay, here are those answers, number 1. Okay, I'll let y'all just read it. Check it. Okay, rolling. Number 4, I put some other ways that you could have written it. You could x divided by 2. You could also do 1/2 times x, because that's the same thing. Yes, sir. Yes, and by that you can also like rearrange it. X divided by 2 is equal to y. It's the same thing. It's just this number is still equal to that number. It's just which sides are on. Okay. Scrolling down. For this one on the next page, again, it's weird because it's different letters, but just say, okay, that's normally the X, that's normally the Y. What are they doing to W to get B? Very good. Thank you. Okay. Again, it's not A because they're not multiplying their output times 4, they're multiplying the W. Okay. Any questions, clarifying things? Yes.
On number 2.
On that third page, right?
Yeah, on the other page.
Number 2. This one, right?
Yeah.
Yeah.
I got confused.
Okay. Go ahead.
You said there was no
Subtractive. Correct. There is not a subtractive pattern, but you can have subtraction in your patterns, okay? You always want your y, you want it to equal, you want to do all the math for your x so that you get your output of y. So if you put, A as your answer, again, you want to always work with your input value and do whatever rules to that, okay? Because you can, I could rewrite this as an addition problem. Y is equal to x minus 5. How could I rewrite that if I wanted to write it as an addition problem? Yep. No. That technically yes, but no. Still having y equals. Y equals not x plus 5. No.
Y equals x plus negative 5.
Y equals x plus negative 5. There you go. That's how you do it. Well, it's not too bad since we practiced it this year, because you keep the first and then you change it to adding the opposite. That was definitely what we talked about back in integer rules, which is still important to know. Okay? We're going to practice this a lot more, this rewriting again and the negatives are coming back. We're going to get you. You're going to come back. All right? So your homework page is that this one right here. Make sure you check it on